Today we'll start with computer hardware chapter. In this chapter we have done earlier logic gates, derived logic gates, logic circuit diagrams, universal logic gates, adders, half adder, full adder, definition, difference between them, their truth table, boolean expression, equations for sum or carries, and logic circuit diagrams of both half adder and full adder. All this we have done earlier. Now today we will start with encoder. Process of converting one type of signal into another. This process is known as encoding. And the logic circuit which performs this task, this job, is known as encoder. Okay, so encoder is logic circuit which performs this conversion from one type of signal to another type of signal. Okay, so it's a logic circuit that is used to convert a number from any base to binary. For example, from decimal to binary, from hexadecimal to binary, or from octal to binary. Okay, so it's a logic circuit that is used to convert a number from any base to binary type. Okay, now come to decimal to binary encoder first. This encoder converts decimal numbers to equivalent binary numbers, and we are talking about decimal. So what is the base of decimal number system? Base is 10. From 0 to 9 numbers are there in decimal system. Decimal, if we are talking about decimal numbers, it means we are talking about 0 to 9, total 10 numbers. Now if we want to convert these 0 to 9 total 10 numbers into binary, fine, then these will be the input lines. 10 input lines will be there from 0 to 9. These are the input lines. We have to convert these numbers to binary. Fine. Then how many output line will be there? To make logic circuit diagram, you must know how many output lines will be there. How to calculate? 2 to the power n must be greater than or equal to I. What is I? I, total numbers to be encoded. And in case of decimal to binary conversion, decimal to binary encoder, okay, in this case the total numbers are 10. So the value of I is 10. So 2 to the power n must be greater than equal to 10. Here I is 10, 2 to the power n greater than equal to 10. Now to make it true, n must be 4. Okay, 2 to the power 4 greater than or equal to 10. If we take the value of n 4, then this condition will be satisfied. Okay, so to make it true, n must be 4. Therefore, the total number of output lines in case of conversion from decimal to binary, okay, decimal to binary encoder, there will be 4 output lines and 10 input lines. Now how to make the logic circuit diagram? Firstly, we will see the truth table of this. We need to convert numbers, decimal numbers into binary. So decimal numbers are from 0 to 9. Make the truth table first, then it will be very easy for you to make the logic circuit diagram. Decimal numbers, write down the decimal numbers from 0 to 9. Now 4 output lines. You can name as A, B, C, D also. I have taken F3, F2, F1, F0. Okay, these are the output lines. Now write down the binary equivalent of these decimal numbers. For 0, the binary equivalent will be 4 output lines there. So 4-bit answer will be there. 0, 0, 0, 0. 1 for 1, 1. For 2, binary is 1, 0. Rest of the values will be 0, 0. For 3, the binary word will be 1, 1. Rest will be 0, 0. For 4, 1, 0, 0. Like this, you will complete this truth table first. Make the truth table. Okay. Now check. in F0, wherever you are getting 1, okay, just write down the values. I have written in F0 has value 1, high signal, where for 1, 3, 5, 7 and 9. Okay, so these input lines will be connected to these input lines. Number 1, number 3, number 5, number 7 and number 9 input line will be connected to F0 OR gate. This output line. These input lines, these number of input lines will be connected to this output line. Okay. Now in this F1, 2, 3, 6, 7. These input lines will be connected to F1. Then F2, 4, 5, 6, 7 will be connected to F2. And in F3 there will be 8 and 9. Okay. Remember F3, 8 and 9, F2, 4, 5, 6, 7. Now come to diagram. We need to convert decimal numbers to binary. So there will be 0 to 9, total 10 input lines like this. Just make a straight line, then 9 sleeping lines. Okay, then number them 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine. These are the switches. Fine. Now I told you F3, F2, F1, F0. We were getting 1. Where? 1 in 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. So here from 1. Input line 1. You will draw a line to this. 1 from 1. From 3, number 3, from number 5, and from number 7 and from number 9. Okay. You will be making the lines to this OR gate, that is F0. As in F0, the values you are getting ones in 1, 3, 5, 7, 9. There is a symmetry also. Alternatively, we are making these lines. Okay. Leaving 1 from 1. Starting from 1, then leave 1, then this, then leave 1, then draw this, then leave 1, then draw this, then leave 1, draw this. Okay. Then for F1, or you can say A, B, C, D, whatever. F1. In F1, 2, 1 value is for 2, 3, then 6 and 7. 2, 3, 6, 7, F1. So draw the lines from 2, 3 and 6, 7 to F1. Fine. Similarly for F2, 4, 5, 6, 7. So draw the lines from input lines 4, 5, 6, 7 to this. Okay. Then for F3 from 8 and 9. Fine. Now this circuit is capable of converting 0 to 9 decimal numbers to equivalent binary. And the switches, these switches are push buttons which provide a high input to attached OR gate. Okay. These are the push buttons. These switches are the push buttons which provide high input to the OR gate. And output of 4 OR gates form a 4-bit word which is binary equivalent of the pressed switch. Suppose if you are going to press the 6th push button, this one is pressed, then 6th, then this one, F2 and F1. If you are going to press this 6th push button or switch, then F2 and F1 our gates are getting high inputs. Okay. In this line only 2, 1 are there. this and this to F1 and this one is to F2. So on pressing this switch or push button, we are getting only F2 and F1 are getting high inputs. Okay, hence producing high output also. So therefore the output will be for 6. If you are pressing 6, the output will be for F2, F1 you will write 1 1 as they are getting high, 1 1, and rest will be 0. Fine. And this one is equivalent of 6. Fine. This is just to explain you. You don't need to calculate like this. Okay. You just have to prepare what is an encoder, definition, then decimal to binary, hexadecimal to binary, octal to binary, all encoders, their logic circuit diagram, their truth table, their block diagram also. Now come to what is a block diagram. You will make a block like this. One box will be there, block will be there. You will write down encoder. From 0 to 9 you have to show 9 input lines and 4 output lines this way. Very simple. Okay, in examination if block diagram is asked, then you have to make this, not that big logic circuit diagram. No need to make that. Okay, if encoders block diagram, decimal to binary encoders block diagram has been asked, then you will be making this diagram. Fine. Now come to hexadecimal. Again, if you will make the truth table of this hexadecimal numbers, then you will be getting that in hexadecimal number system the base is 16, so from 0 to 15 input lines will be there. You will be making 16 lines, input lines. Similarly, but in this system in hexadecimal from 0 to 9 numbers will be there, and 9 onwards there will be A, B, C, D, E, F till 15. Okay. Again 2 to the power n is greater than equal to I. So n must be, to satisfy that condition, there will be 4 output lines. So 4 OR gates will be there. You can say A, B, C, D or F3, F2, F1 or F0. Fine. The block diagram will be this. From 0 to 15 input lines you can show like this. Encoder 4 output lines. This will be the block diagram. Now come to logic circuit diagram. You will, if you have been asked to make the truth table, then you will be making truth table. Otherwise, if the logic circuit diagram is needed, then you will be making logic circuit diagram only. No need to make the truth table in that case. Okay. So if you have to make the logic circuit diagram of hexadecimal to binary encoder, if we make the truth table, then we will be getting in F0. Okay, in F0 we will be getting 1 in input lines number 1, 3, 5, 7, 9, B, D, F. So just draw the lines from these input lines. 1, 3, 5, 7, 9, B, D, F. Alternatively we are drawing these lines. Okay, so be careful in making this logic circuit diagram. Now in case of F1 we will be getting in truth table 1 in this 2, 3, 6, 7, A, B, E, F. Okay, so 2, 3, then 6, 7, then A, B, then from E, F. Draw the lines. Okay, and F1, then F2, 4, 5, 6, 7, then C, D, E, F. And in case of F3, 8, from 8 to 15 means F. You will be drawing the lines. Okay. Make a logic circuit diagram is a very easy task. Okay. First make a truth table, then you can easily make the logic circuit diagram. Otherwise you can make the logic circuit diagram directly also. No need to make the truth table first if you are able. Okay. Now octal to binary encoder. It's a 3-bit encoder. Octal numbers are represented from 0 to 7 and the base is 8. Okay, from 0 to 7. So total numbers are 8. Now to satisfy this, to make it true, the value of n should be 3, not 4 in this case now. Okay. So how many 3 output lines will be there? Means 3 OR gates will be there and 8 input lines will be there. You will be making 8 input lines and 3 output lines, or you can say 3 OR gates you will be making in logic circuit diagram. Fine. Just see the truth table. Octal numbers are from 0 to 7. Then binary output, what will be the binary output? 3 bits will be there, A, B, C. Zeros binary will be 0, 0, 0, 1, binary equivalent 1, 2, 1, 0, 3, 1, 1, 4, 1, 0, 0, 5, 1, 0, 1, 6, 1, 1, 0, 7, 1, 1, 1. These are the binary equivalents. Fine. So in A, we are getting 1 in from line number 4, 5, 6 and 7 simply. So from in A OR gate, you will be drawing the lines from 4, 5, 6 and 7. Then B, 2, 3 and 6, 7 we are getting 1. So from 2, 3 you will be making lines and 6, 7 also. Okay. And in case of C, this is C. 1, then 3, then 5, then 7. 1, 3, 5, 7. Draw the lines. Okay. This way you can make the logic circuit diagram very easily from the help of truth table. Okay, with the help of truth table, or you can make the logic circuit diagrams directly also. Okay, whatever the method you can use, whatever you feel comfortable with, whichever method is easy for you. Okay. Now the block diagram also. How to make block diagram of this? 8 input lines will be there from 0, 1 till 7. Okay. Then again this is encoder. And how many output lines? 3. These are the output lines. Okay. So this is octal to binary encoders block diagram. Fine.